Addition and subtraction of integers. Let's start with addition. Now, we learned some properties of addition for the whole numbers earlier, like closure, associativity, commutative, has an additive inverse, has an additive identity of 0. All of those still apply for the integers as well.
Okay, so these counters are actually really great for adding, in my opinion. Let me get a marker. Okay, so let's look at, let's say, 5 plus 3. That's pretty simple. So that's 5 blacks, 2, 3, 4, 5, and then 3 more of the black ones, which gives me 8 total, okay? Now what if I have 5 plus negative 3? Well, now these are red. I can flip this one. And now I'm going to have some of these guys are going to cancel. So those go together, those and those, and I'm only left with a positive 2 that didn't cancel out. And we know that that's the answer to that problem, don't we? Okay, what if we have a negative 6 plus negative 3? Well, these are all going to be red. So I have 1, 2, 3, 4, 5, 6, and 1, 2, 3 red ones gives me 9 red ones all together. What if I have negative 6 plus 3 positive? Well, then these all neutralize together. They're going to make zeros, and I'm only left with these 3 negatives over here. They didn't have anybody to pair with. Okay. So that's how that works. The addition is pretty straightforward.
Okay, let's use the number line now to show addition of integers. We're going to start with something really simple, 2 plus 3. So we start at 0, we make a jump of 2, we draw our arrow, and then at that arrow we start the next jump and we make a jump of 1, 2, 3. Mr. Frog's on the lily pad, he ends up on lily pad number 5. Okay, sorry this is kind of sloppy. This digital pen is wiggly here. It thinks I'm signing my name at Walmart, I guess. Alright, so let's look at a negative example. Let's look at negative 4 plus negative 5. So again, we start at 0 and we go to the left to the negative 4. We pick up from there and we go down 1, 2, 3, 4, 5, and we land on negative 9. Those are pretty straightforward. Where it gets complicated is when we mix it up and have both, right? So let's do that. Let's start with 10 plus negative 7. Okay, so I start at 0 and I make my jump to 10, and then I pick up where that arrow left off and I jump back 7. 1, 2, 3, 4. And that'll land me on negative 3. So, land me on 3, not negative 3. Okay, So that's how that one works. Let's try another one. Let's do 3 plus -6. Okay, so I'm going to jump from 0 to 3, but then I'm going to start there and go backwards 6 places. 1, 2, 3, 4, 5, 6. So that lands me on -3. Okay. Let's do -3 plus 5. So we start and go backwards to -3. And then we pick up from there and go up 5 places. And we land on 2. Okay. All right. Let's do maybe one more, making sure I've got all the possibilities here. Okay, let's do this one. -8 plus 5. So we go backwards to -8, and then we're going to go up 5 units, and that's going to land us, let me redo that, that might be a little too, there we go, 5 units to -3. It's just like playing a board game. We go backwards 8 and then up 3. Subtraction. Now subtraction is actually closed in the integers because we can include the negative numbers now.
Okay, so for subtraction, we want to think about it in terms of takeaway. Okay, so here I have, what is that? 1, 2, 3, 4, 6. Okay, 6 take away 2. So we're starting simple. I have 6 positives. Got to take away 2. That leaves me with 4. Okay. Likewise, if everything is negative, let's see here. 1, 2, 3, 4, 5, 6, 7. We'll do 8. All right. I have -8. I want to take away -3. So I'm going to take 3 of these away. That's going to leave me with -5. Now, if you recall, when we would do this in, say, algebra, we would often say, well, that's just the same as 8 plus 3 equals -5. Isn't that how we work that? Now, this is why that works. If I have, let me go and put my -3 back that I took away. If it's 8 and I take away 3, and it's the same as if I added +3, is the same effect. Taking away these 3 is the same as adding these three and they neutralize. The same effect happens. So that's why those are equivalent. Okay, so far, everything we've had has had the same signs as far as subtraction. Let's look at one that doesn't. Okay. What if I had, oh, we just did 8. Let's do something else. 7 minus -4. Okay. So I'm going to start with 7 of the positives. That's 1, 2, 3, 4, 5, 6, 7. And this says to take away 4 red. I don't have 4 red ones there to take away, do I? So what am I to do? Well, what we do is we have to be very clever here. I am supposed to take away 4 red ones. I didn't have 4 red ones. But what I can do to get my 4 red ones is if I add 4 red with 4 black, they will neutralize. This still is just +7 because I have 1, 2, 3, 4, 5, 6, 7, 0, 0, 0, 0. This is still +7. But because this +7 has these clever zeros over here, then I can finally take away 4 of these negatives. And now I am left with 7 plus 1, 2, 3, 4. Which is equal to 11. And so it follows that what we typically would do is say, well, if you subtract a negative, you're just adding the positive. And that's why that's so.
Okay, so let's subtract with the number line now. Remember when we added, say, 2 plus 3, that our arrows went head to tail. Head being the arrow, tail being the one not. So 2 plus 3 would look something like that. In subtraction, the arrows are going to meet up. Positive are jumps to the right. Negatives are jumps to the left. Arrows together. All right, let's start simple. Let's do 5 minus 2. So I make a jump of 5 and a jump of 2. 2 is always a jump to the right. And we line up our arrows. So I have a jump from 3 to 5, that's a length of 2. So my answer is equal to 3. It's like we deleted this little spot right here. We took out that, and what we were left with was 3. It's kind of a missing add-end idea. Okay, so let's look at -4 minus -2. So I jump to the left to the -4, and then I pick up with the arrow at the same place, and then I have a jump of -2 that goes to the left that I took away. And where I am right here is my answer. That's -2. Now these are the most straightforward ways. I took a positive and I subtracted a positive. I took a negative and I subtracted a negative. Now let's mix them up. So let's have 6 minus negative 2. So let's go to 6 with our arrow. I need for my arrows to line up, but negative 2 goes to the left 2. So if the arrows line up right here, and this one was a jump to the left, then it's going to have to start here. Okay? For the arrows to line up and this be negative, negatives move to the left, I've got to start at 8, and that is, in fact, my answer. Let me just write it over here. Minus negative 2 is a positive 8. And we knew that because that's the same as 6 plus 2, isn't it? So this one's a little harder than the adding for sure. So if it seems a little bit harder to process, that's because it is. I'm trying to get this to delete. You know how my auto shapes don't always want to. They're very nice when I want a shape. Oh, come on. I might just have to have a nice little circle up there. Okay, oh well. Let's look at negative 8 minus 2. So we're going to the left to negative 8. My arrows have to line up. A positive 2 is going to look like that to the right. So if this arrow lines up here and it was a move to the right, then it must have started over here at negative 10. The end of it. 1, 2 jumps, so that is a negative 10. Let's do some more, just because I think this is a little bit more confusing. Let me try to get that away one more time. Maybe if I zoom out. Yay. There we go. Okay, so let's do 8 minus negative 6. So I'm going to go over to the 8. Negative 6 is a jump to the left. The arrows must line up. So this one's coming from this way, 6 out. 1, 2, 3, 4, 5, 6. So that one starts at 14 and jumps there. So that is equal to 14. Let me do 6 minus 2. We'll do something straightforward. So we go to 6 and we take away 2. So that's equal to 4. I'm going to do one more. I'm going to do negative 11 minus positive 5. So I go to the left to negative 11. Positive 5 would move to the right. Ooh, maybe I should have done a 4. My number line isn't big enough. Let's do a 4. 1, 2, 3, 4. Positive jump goes from there, and we get negative 15.